So now that we have our gradient, let's revisit our directional derivative, du of f of xy. Remember that this was f, my partial derivative at x, times cosine theta, plus my partial derivative of y, sine theta. But I can now rewrite this as a dot product. It's the dot product of the vector fx I plus fy j dotted with the vector cosine theta I plus sine theta j And so this means that I can think about my directional derivative in a different way. I can think of it as being the dot product of the gradient. So that's this first part dotted with the second part, which is the vector u. So this gives us a whole new way. It's not really a whole new way, but it's a different formula for the directional derivative now in terms of the gradient. So let's look at an example here. Find the directional derivative of the function. It's going to be 3x squared minus 2y squared at the point negative 3/4, 0 in the direction from the point negative 3/4, 0 to the point 0, 1. So here they technically haven't given me my specific vector u, so I have to find that. Well, they told me that I'm going from this first point, I'll call it P, to the second point Q. So I can form the vector PQ. Right? It's a terminal minus initial 3/4 I plus 1 minus 0 j. So that means PQ is going to be the vector 3/4 I plus j. Now this vector is not a unit vector, so I need to find the magnitude of this vector. So you're going to square 3/4 and 1, so 9 over 16 plus 1, which is 16 over 16. So you'll get square root of 25 over 16, or 5/4. So to get my vector u, I need to take my vector PQ, and I need to divide by the magnitude of PQ. So when I divide by 5/4, it's like multiplying by 4/5 times my vector. So in the end, my unit vector u is going to be the vector 3/5 I plus 4/5 j. So there's my vector u. I'm going to want to remember that, so maybe I'll underline it here. That's my vector u. So now I need to find my gradient. The gradient of f of xy. What's the partial derivative of my function with respect to x? Maybe I'll rewrite my function here. It's 3x squared minus 2y squared. The derivative would be 6x I. And then the derivative with respect to y would be negative 4y. And then I'm going to plug in my point, which was negative 3/4 and 0. So I get negative 9/2 I and a 0j. So we go to our formula for the directional derivative du f negative 340. It's the dot product of my gradient at my point with the vector u. So if I take the dot product of the two vectors here, I'm going to get negative 9/2 times 3/5 plus 0 times 4/5, or I'll get negative 27 over 10. And there is my directional derivative for my function at that point.